Hello everybody, welcome into another lesson. Today we are going to talk about real numbers. And we are going to introduce negative numbers for the first time today. So we are shifting gears a bit from what we have been doing, and also I can tell you we have entered the final unit of Basic Math 2. We are in the final 6 lessons of Basic Math 2. Within a week we'll be in pre-algebra, so look forward to that coming up too. But we are going to start today by climbing a number tree. I've already made out a number tree. Let's start at the bottom of this tree and climb our way up. So you have natural numbers, which up till now, all the way from basic 1 up till now, we've been working with natural and whole numbers. Natural numbers, of course, being your counting numbers, 1, 2, 3, 4, 5, and so on. Numbers you can count with. Natural numbers are a subset of the whole numbers. The whole numbers are all of your counting numbers plus 0. So you'll have 0, 1, 2, 3, 4, 5, and so on for your whole numbers. So we've climbed our way from natural to whole numbers. Now we got to talk about integers. We will talk about integers, which are of course your whole numbers, but also their opposites. So let's say you have 5, right? The opposite of 5 is negative 5. You have 3, the opposite of 3, that's negative 3. So integers include all positive and negative counting numbers. We will get more into negative numbers in a minute, but integers include all positive and negative whole numbers. So we climb from integers to rational numbers. Rational numbers are all integers or any numbers that can be expressed as a fraction. So even the number 2, we can express as a fraction because that's 2 over 1. Well, we have 2/3. That's a rational number. We have 1.65. That would be equal to 1 65/100ths, which is equal to 1 13/20ths, which would make that a rational number. So a rational number is any number that can be expressed as a fraction, whether it's a whole number or a decimal that can be expressed as a fraction or a fraction itself. So we got natural numbers, the counting numbers being the subset of the whole numbers, which are all the counting numbers plus 0. The whole numbers are a subset of the integers, which are all the counting, it's all the whole numbers. In addition to the whole numbers, it's all the negative whole numbers. And then those integers are a subset of rational numbers, which are all integers, which is any number that can be expressed as a fraction also. It's all integers and any number, whether decimal, fraction, or whole number, that can be expressed as a fraction. Now, off to the side in its own little world, we have irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction, such as pi. We know pi is approximately equal to 3.14, but it's a number that keeps going. Pi is the prime example of an irrational number. You could also have the square root of 2, the square root of 71. Any number that has a square root of not a perfect square is an irrational number. So square roots of non-perfect squares, or any number in general that cannot be expressed as a fraction, is an irrational number. So together, the rational and irrational numbers make up what's called the real numbers. All these together make up the set of real numbers. So from now on, get used to working in real numbers. From here on out and in subsequent courses, you will also be incorporating negative numbers and irrational numbers into your studies. Well, you may be asking, well, there, of course there's real numbers. Is there such a thing as imaginary numbers? Actually, there are, but those won't come into place till Algebra 2. If you put real numbers and imaginary numbers together, you get what's called complex numbers. Those two together make up the complex numbers. But for today, we're only, and up until Algebra 2, we're only going to talk about real numbers. So, if you can understand the natural numbers are a subset of whole numbers, the whole numbers are a subset of the integers, and the integers are a subset of rational numbers. And then you have out there on its own, hanging out by itself, the irrational numbers. And when you put the rational numbers and the irrational numbers together, you have the set of real numbers. So that's all that is. Okay, so we've dealt with our number tree. Let's talk about negative numbers. So let's plot a number line here, right? Let's plot a nice number line. We'll put 0 in the center. You go to the right, of course, you're going to have positive numbers. You'll have 1, you'll have 2, 3, 4, 5, and it just keeps going infinitely to the right. It can go to infinity to the right for your positive numbers. To the left of 0, you have negative numbers. So you would have negative 1, negative 2, negative 3, negative 4, negative 5, and so on. So we notice to the right of 0 are your positive numbers, which are greater than 0. To the left of 0, you have negative numbers, which are all less than 0. Now, as we know with positive numbers, which are all greater than 0, the bigger the number, the bigger the number, the greater it is. When we deal with negative numbers, the bigger the number, the smaller it actually is. It works the opposite with negative numbers. For example, let's say we have 1 and 2. Well, we know 1 is less than 2. 1 is less than 2 because it's smaller than 2. By the same token, we could say 2 is greater than 1. Because, yeah, 2 is bigger than 1. 2 is greater than 1. However, take any negative number, it is less than 0. Or by the same token, you could say 0 is greater than any negative number. Where if it were a positive number, 0 would be less than any positive number. So, let's do an inequality here. Negative 5 and negative 4. Is negative 5 going to be bigger than negative 4, or is it going to be less than negative 4? Well, remember, when we have negative numbers, we're actually going the opposite way. So negative 5 will be less than negative 4. So negative 5 is less than negative 4. Or you could say that negative 4 is greater than negative 5. Because when you work in the negatives, the smaller the number gets, the bigger it's getting. When you work in the negatives until you arrive at 0, and then it just keeps getting bigger the further right you go. So with negative numbers, it's a bit of reverse psychology from positive numbers. So let's say we have the point negative 3 on the graph, and we have the point positive 3, or regular 3. How far away from 0 are they? Negative 3 is 1, 2, 3 units from 0. 3 is 1, 2, 3 units from 0. Okay? Well, both negative 3 and 3 are both each 3 units from 0. If we want to figure out how far a number is from 0, you're going to take what's called the absolute value. So, these symbols besides the number is called the absolute value. These long vertical marks next to the negative 3, that's the absolute value. To find the absolute value of a number, no matter whether it's positive or negative, it's positive. You would get the answer, the absolute value of -3 is 3. Or you take the absolute value of 3. Well, whether the number inside the absolute value is positive or negative, it's positive. The answer would be 3. So if you want to find how far away a number is from 0, you would take the absolute value. Let's say we had the absolute value of -76, right? Well, the absolute value of -76, you just make it positive. It would be 76. Absolute value of -76 is 76. So it's 76 units away from 0. Let's say we have the absolute value of positive 108, right? Well, whether it's positive or negative inside the absolute value, you just make it positive. So the answer would be 108. So that's absolute value, which means finding the distance from 0. Okay? So remember, when dealing with the negative numbers, it goes the opposite way. The bigger the number gets in the negatives, the smaller the number is actually getting. Whereas in the positives, as you know, the bigger the number gets, the bigger the number is actually getting. So, let's see. -6 and -5, right? Is -6 less than -5 or greater than -5? Well, if it were 6 and 5, if the numbers are both positive, we would definitely know 6 is greater than 5. But when you have both numbers negative, it goes in reverse. The bigger number is actually smaller when they're both negative. So -6 would actually be smaller than -5. Now, of course, we have 2 and -5. Which number is bigger? Well, a positive number is bigger than a negative number any day of the week. So we didn't even have to think about that one. 2 is greater than -5. So just know again, to the left of 0 is all your negatives, to the right of 0 is all your positives. The bigger the number in the negative, the smaller the number actually is. The bigger the number in the positive, the bigger it is. And to find the distance from 0, let's say we have the absolute value of -99. Let's assume we had a board that big and I go all the way back to -99. The absolute value means how far away from 0 is it. The number inside of the absolute value does not matter whether it's positive or negative. It'll always be positive for the answer. So it is 99 would be the absolute value of -99. It'd be 99 units away from 0. So really, that's all I have for real numbers today. Tomorrow, or I should say the next lesson, it may be tomorrow, may not be. The next lesson is going to be addition of real numbers, which is when we'll bring in negative numbers into addition. I hope everybody has a good night and take care.